Okay, moving on to the next part of Chapter P, Section 2. Power rule, powers to powers. So if I look at this example right here, this is a power, 4 to the second power, raised to a power. That's what this is, powers to powers. So I'm going to take that 4 to the power of 2 and raise it to the power of 3. And what do I do with the exponents? Any guesses? Well, let's look at what this means. 4 squared cubed really means 4 squared times 4 squared times 4 squared. Right? 4 squared 3 times. And 4 squared means 4 times 4, and the second 4 squared is another 4 times 4, and the third 4 squared is another 4 times 4. And now let's count them. How many 4s do we have? 1, 2, 3, 4, 5, 6. We've got 6 of them all together. So this really equals 4 to the power of 6. So looking at this, 4 squared raised to the third power, what do you think you do with the exponents to get 4 to the power of 6? Correct, you are going to multiply them. So when you have a power to a power, you multiply the exponents. You know, parentheses always make me think of multiplication. And so when I see the parentheses in between, I automatically know that I have to multiply 2 times 3 to get 6. So I could have automatically thought of this as 4 to the 2 times 3 power, which is 4 to the power of 6. And again, you have a numeric base raised to a numeric exponent. This, when you put on your calculator, is equal to 4,096. Y to the power of 4 raised to the power of 3. You already know what the rule is now. And so we know this is going to be y raised to the 4 times 3 power, or y to the power of 12. Again, another example, x raised to the negative 3 power, raised to the second power, power to a power. Again, you're still going to multiply the exponents. Negative times positive is a negative. This becomes x to the negative 3 times 2, which really is x to the negative 6 power, which becomes 1 over x to the power of 6. I can't simplify x to the power of 6. So the x is a variable base. It's not a numeric base, so I have to just keep it like that. If you have any questions, post a comment on the discussion. Quotient rule. Quotient means division. So when we divide rational expressions with the same non-zero base, what do you suppose we do with the exponents? Well, let's look. Let's write out 3 to the power of 6. That's 3 times 3 times itself 6 times. There it is, 6 times. Divided by 3 to the 4th is 3 times itself 4 times. Now remember, any number divided by itself is equal to 1. So these are going to divide out. I like the phrase divide out. Please don't use cancel. These numbers divide out. They become 1s. That divides out, that divides out, that divides out. How many 3s are left? Yes, you're correct. There's 2 3s. Where are they? In the numerator or the denominator? You're right. They're in the numerator. This becomes 3 to the power of 2. So what do we do with these exponents then to get it to be 3 to the power of 2 so that we don't have to do all this nonsense? Well, if I take 6 and the 4, subtraction. And for me, in my brain, this division sign almost looks like a subtraction sign. And so that's my little mnemonic device that helps me remember that I have to subtract the exponents. Okay, so I'm going to write a big OR here and say this would be 3 to the 6 subtract 4, which is 3 squared. And of course, we know numeric base raised to a numeric exponent, 3 squared is 9. So you'd always want to simplify it at the end if you can. Now that we know what the rule is that you subtract the exponents, well, this would be x to the 3 subtract 11. 3 subtract 11 is x to the power of negative 8. Remember, we don't want any negative exponents. We have to write this as 1 over x to the power of 8. You know, I would do here what I did in that last video lesson. 3 of these, kick out 3 of those, leaving me with 8 in the bottom. I like to expedite my my solving and my simplifying techniques. Okay, what does the quotient rule say? The quotient rule says that as long as the bases are the same, you can subtract the exponents. Now be careful with this one because this is for subtract. This is the part of the rule, the subtract. And what am I subtracting? I'm subtracting a -9. So be cognizant of the fact that you've got a negative in the bottom. Yes, when it comes up, it's going to go positive, and notice that. You know, I move this up, the exponent on the y becomes positive, and I have same base multiplication, I would be adding the exponents. This double negative would turn into addition. So this is really y to the power of 13. Or, excuse me, you could think of this as y to the power of 4, just like I said, times or being multiplied with y to the power of 9 because you're bringing the negative exponent up. See, these two are both now in a numerator, you know, over 1. And this now, you're going to add the exponents. This is y to the 4 plus 9, which is y to the power of 13. Either way, you get the same answer. What do we do when we have a product and we're raising a product to a power? Let's look. We have a product. There's two things inside the parentheses. It's not addition or subtraction. They're being multiplied. And the result of a multiplication problem is called a product. So 3x, that thing raised to the power of 3. Well, let's write out what that means. This is really 3x times 3x times 3x, 3 times. And if I rearrange, you know, 3 times 3 times 3, well, isn't 3 times 3 times 3 3 cubed? And x times x times x would be x cubed. And 3 cubed, of course, we would have to simplify this. The x cubed, we couldn't because we don't know what x is. But what do we do with this exponent on the outside and the exponents that are on the inside? Well, first of all, you have to realize what the exponents on the inside are. Isn't this really 3 to the power of 1? And this is really x to the power of 1? Well, what operation would I do with the 1 and the 3 to get it to be a 3? And you say, multiplication, absolutely. But I'm not just multiplying this 3 with this exponent, I have to multiply it with this. So that's really what property? And you say, distribute. So you're going to distribute the power to each factor, to both the 3 and the x. Okay, what we really mean here is we're doing 3 to the 1 times 3 power, and then x to the 1 times 3 power. And that's exactly how I say it in my brain when I'm doing this, even when I'm doing new problems that I haven't seen before. I look at this and I say 3 to the 1 times 3 power, x to the 1 times 3 power. 3 to the 1 times 3 power is 3 cubed. X to the 1 times 3 power is x cubed. And notice this thing and this thing are exactly the same. Of course, then 3 cubed is 27. And x cubed, I can't do much with x cubed because I don't know what x is. So this is my answer in simplified form. Excuse me. Now, put your exponents on your bases. This is a numeric base. These are variable bases. That's a 1, that's a 1, that's a 1. So I'm writing this, and notice the negative. The negative is inside that grouping, okay? Because I'm squaring it, okay? It's inside. This is parenthesis -5 to the 1 times 2 power or square, r to the 1 times 2 power or square, s to the 1 times 2 power or square. Because the negative's inside that I'm squaring, that negative is going to go positive, and so my simplified answer is 25 r squared s squared. Not too bad. Okay, side 2. Quotients to powers. Now here I've got a quotient, 3/4 raised to the power of 2. When a quotient is raised to a power, what do you do? Something, the power to both the numerator and the denominator. Well, multiplication and division are inverses, so it would make sense that this same thing would apply. Let's see. 3/4 squared really means 3/4 times 3/4. And 3 times 3 really means 3 squared, and 4 times 4 really means 4 squared. And so remember, what are our exponents on these numeric bases inside? That's a 1 and that's a 1. So here I really have 3 to the 1 times 2 power, and here I have 4 to the 1 times 2 power, or 4 squared. And so you're doing the same thing. It is distributive property. You've got to distribute that exponent to every item in the numerator and in the denominator. All right, and of course we know that 3 squared is 9 and 4 squared is 16. Now that we know the rule, here, the negative is being cubed. So this thing is going to end up being what? Positive or negative? Give you a moment to think of that. Remember, any negative being raised to an odd power is always going to be negative. Any negative raised to an even power is always going to be positive. So my final answer here is going to be negative. I'm taking care of the cubing of the negative right away. Now I'm going to say this is 2 cubed because this is 2 to the 1 times 3, or 2 cubed. And this is x to the 1 times 3 power, or x cubed. And when I cube a 2, I get 8. And when I cube an x, I get x cubed. And don't forget, it has to stay negative. This thing is equivalent to negative 8 divided by x cubed. Not too bad, not too difficult. Okay, properties of exponents summary. Well, here I have a b, my variable is b, raised to the negative n power. Well, what do we do when the exponents are negative? We take it from the numerator and move it to the denominator. This becomes 1 over b to the power of positive n. b, the base, to the 0 power. Well, that always equals 1. b to the m times b to the n. Now, the bases are the same. The exponents are different. Operations multiplication, what do you do with the exponents? You add them. b to the m plus n. This is a power raised to a power. What do you do with the exponents? Notice we see, or I see, the parenthesis here. I know I have to multiply those exponents. This becomes base b to the m times n power. This one here, division, same base. I'm going to subtract the exponents. This becomes b to the power of m, subtract the power of n. A times b raised to the n power. This is a product to a power. I have to distribute the exponent. The exponent on a and the exponent on b are both 1. So this becomes a to the power of n times b to the power of n. And in a similar fashion, a divided by b over n, I'm going to distribute again and end up with a to the power of n over b to the power of n. So it would really help you out a lot if you learned and memorized all these properties so that you're pretty fluent with them. You'll see when we do some of these examples down here. They're not difficult, but sometimes it gets a little bit tricky when you're like, wait, what property? What are we talking about? Okay, last thing on the note sheet before the examples, and then after the examples we're going to be done. Excuse me, in the next video, we're going to take a look at exponents in scientific notation. But let's talk about what we mean by when we say an exponential expression is in fully simplified form. Well, this will be true if no parentheses appear. So if I look down at these examples at the bottom of the page, I've got some parentheses. I've got to get rid of them. No parentheses can appear. Also, no powers are raised to powers. If I have a power to a power, I need to simplify it. I need to get rid of that power to a power. It's too much to look at. Also, each base occurs just one time. I can't have stuff in the numerator and in the denominator. I can't have a to some power in the numerator and in the denominator and say it's simplified. I need all the a's either upstairs or downstairs. They can't be both places. Or I can't have, 3 times a times b to some power times a to some power. You got to combine and show that each base is going to occur just one time. So each base occurs only once. And of course, one of the biggest ones here is no negative exponents up here. So get rid of those negative exponents. Okay, ready for the examples? So here we have a product raised to a power. We have parentheses, we have a negative sign. This negative is being raised to the power of 3. Now, it's going to stay negative anyway because we know a negative to an odd power is going to be negative, but I'm still going to write my work of what this means. Negative 3 cubed, x to the, what do I do with these? Multiply 2 times 3 is 6. Y to the 3 times 3 is y to the 9th. Be careful that you are multiplying and not adding, okay? And then, of course, if I take a negative and raise it to the third power, it stays negative, and 3 cubed is 27. So that is how I simplify that problem. I'm going to make little lines. I'm going to puzzle my page here so that I don't run into each other. All right, notice, this is not a product to a power. I mean, you could think of it as that, but the power on the outside is 1, so it seems kind of silly to do that. But what you can do with these types is rearrange it, because this is a numeric base to the power of 1, and this is a numeric base to the power of 1. So you can think of this as negative 8 being multiplied with 2, and then x to the third times x to the first, and y to the fifth times y to the eighth. That's what, at the very least, you should be thinking of in your mind. 8 times 2, of course, is 16. Don't forget it is negative, so that's negative 16. Same base, multiplication, you add the exponents. This is x to the power of 4. And same base operation is multiplication, so you add the exponents again. This is y to the power of 13. And I'm finished because I see each base only one time. I don't have any parentheses, no powers are raised to powers, and I don't have negative exponents. I have a negative base, and that's okay. I just can't have negative exponents. The division. I'm gonna like divide this. You know, I'm gonna say, well, this is really the same as 50 over 25, x to the power of 10 over x to the power of 15, and then y cubed over y to the negative 4th. So 50 divided by 25 is 2. I'm gonna pop right to that 2 right away. 10 and 15. Well, look, 10 of these will kick out 10 of those, leaving me with 5 left. Or I could do 10 minus 15 and get x to the negative 5. But remember, I have to clean up that negative exponent later. I could bring this y to the negative 4 up as a y to the positive 4 and see I have a y cubed and a y to the positive 4. And I'm just writing this in the notes this way to illustrate. This has to go down to the denominator, and that's why I wrote this way, because I had to do another step anyway. The 2 stays up. See, this is all over 1. The 2 is a positive 1 power, so it has to stay up in the numerator. That's 2 to the power of 1. These y's both stay up. Same base, multiplication, add the exponents. This is y to the power of 7. And then, of course, this is the one that had the negative exponent. I need to take that down to the denominator. And so this is going to be divided by x to the power of 5. Final answer in simplified form. All of these conditions have been met. Why don't you try the last one? Pause the video. Try it yourself. Okay, I took like a 10-second pause. And I'm going to finish up the video with this last example. Hopefully you did pause the video and tried it yourself. I think I am going to distribute the exponent. This would become 3 to the power of negative 3, x to the power of negative 3, divided by y to the power of 5 times 3, 15. And don't forget it's negative because one of those are negative. Now I've got to take these two elements, or bases, to the denominator to make those exponents positive, and I have to take this base up top. So I'm just going to flip it. This becomes y to the positive 15 over 3 cubed x cubed, And notice 3 is a numeric base raised to the power of 3, so I'm left with y to the power of 15 over 27x to the power of 3 as a final answer in simplified form. Okay, well, hopefully this was a good review for you. We will finish up in the next video with exponents and scientific notation and doing some operations with that, and you will have a small homework assignment. Have a great day.